Okay. Now we're going to be applying this. Now you might have heard a saying before last year. It was so, ka, toa. Now, really what it is, it's in a way of helping us memorize what each ratio works. We go, the sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent leg over hypotenuse. And the tangent of an angle is opposite leg over adjacent leg. Another way of writing that would be like this. So, ka, toa. So it's a way of helping you memorize which ratio to use. Now understand the angle is the key of deciding what you have. So we're going to do these in two different colors. We're going to do angle K first. So angle K I'm going to let be in blue. Now if this is angle K, obviously the hypotenuse is still the hypotenuse. It's opposite the right angle. It's always the longest side. But the one that helps make the angle as a leg is called the adjacent leg. So this would be your adjacent leg. This one over here would be your opposite leg. So now I can use to set this up, and I'm going to use my reference over here. I want the sine of angle K. Well, that's opposite leg over hypotenuse. So that's going to be 11 over 61. And that's all I want. When I want a ratio, that's what I want. All right? The cosine of angle A. Well, that's adjacent leg over hypotenuse. Well, what's the adjacent leg? Oh, that's 60. So that's 60 over 61. The tangent of angle K. Well, that's opposite leg over adjacent leg. So that's 11 over 60. Works pretty easy. Now let's let angle J be red. Okay, so this is going to be the one that we work with. Hypotenuse, obviously still the hypotenuse, but now this becomes my opposite leg, and this one's your adjacent leg. So now we still set these up. What's sine of angle J? Well, sine is opposite leg over hypotenuse. So for J, here's my opposite leg, that's my hypotenuse. So it's going to be 60 over 61. The cosine of angle J, well, that's adjacent leg over hypotenuse. Well, adjacent leg over hypotenuse, we got 11 over 61. The tangent of angle J, well, that's opposite leg over adjacent leg. That's 60 over 11. So it's very easy to set those up. And if you can set those up, you've got the hardest problem of the whole chapter done. You can set up your equations. All right, now we're going to do this one, and we're actually going to just do 1 and 2 for time-wise. To make sure we still understand this. But when we have this one, I want to do it just for angle F. So I'm going to mark angle F on these two. Now I want to get the sine of angle F, I want the cosine of angle F, and I want the tangent of angle F. Don't go sin, cos, tan. That's not what they mean. Say the actual names. Now with that, that means I need to know opposite leg, adjacent leg, and hypotenuse. Well, hypotenuse is easiest. We have our opposite leg, which doesn't make it, and then we have the leg that helps make our angle, and that's your adjacent leg. So now I'm going to set this up. Sine of angle F. Well, that's sine, if I go up here again, is opposite over hypotenuse. So opposite over hypotenuse is 8/10. But can I leave a fraction not reduced? No. The ratio is going to be 4 to 5. Cosine of angle F. What do we have for the cosine of angle F? Cosine for angle F is going to be adjacent leg over hypotenuse, because it's adjacent leg over hypotenuse. So it's just going to be 6 over 10, and that's 3/5. So we have the tangent of angle F, okay? Tangent is opposite leg over adjacent leg. Well, that's 8 over 6, which is 4/3. Not too hard, is it? Now let's do the same type of idea here for number 2. Now for number 2, actually I'm going to change it to red just so we're working with it. If this is my angle, this would be your adjacent leg. This would be your opposite. And your hypotenuse is always your what? Hypotenuse. So the sine for angle F of number 2, and we're not going to do number 3 today, is going to be opposite leg over hypotenuse. That's 5 over 5 root 2. Oh, that's 1 over root 2. Can I leave it in that form? No, we have to rationalize. And I get root 2 over 2. So that's the sine of angle F, its ratio. Now the cosine of angle F, the cool thing is, it's actually the same thing. Well, if it's the same thing, do I need to show that process again? No, I can just plug it in. Now let's do the tangent of angle F. Okay, the tangent is going to be opposite leg over adjacent leg. So we have 5 over 5, which equals 1. So hopefully that helps us set them up. So now I can apply it to setting it up for actual equations.